So let's continue with single, double, and triple bonds. So let's kind of practice what we've learned. And if we were going to draw the dot diagram for oxygen, and remember oxygen is diatomic, so it will always occur bonded to either another element or it'll bond it to another oxygen. And if oxygen has a total of 6 valence electrons, and there's 2 of them, that means we have a total of 12 electrons to place around our 2 oxygen atoms. And this is what it would look like. Now we need to check to make sure that each oxygen individually has a full octet. And this oxygen here has a total of 8 electrons. Here's 4, 5, 6, 7, 8. And then we look at this oxygen and it has 8 as well. Here's 4 total, 5, 6, 7, 8. So we have a stable combination, but we needed to have a double bond between the 2 oxygens. Here's a secret that works about 90% of the time when it comes to figuring out what elements will create double and triple bonds. I use the acronym no COPS. So the elements will be nitrogen, oxygen, carbon, oxygen, and phosphorus and sulfur. These are the elements that will tend to form double and triple bonds. 90% of the time, these will be the only ones we will ever work with. And so if I ever ask you, well, what does no COP say? You'll know what I'm talking about. So now let's check our understanding for nitrogen, 2 nitrogens together. Well, nitrogen has a total of what, 5 valence electrons, and we have 2 of them, so that's 10 electrons we have to place around our nitrogen atoms. And in order to do so, here we would actually have 8 electrons and here 8 electrons, but there's too many. We only had what, 10 to start with, so this is way too many of electrons. Now this won't work either because neither one nitrogen has a total of 8 electrons around it, so that won't work. But if we put a triple bond, which means that they're sharing a total of 2, 4, 6 electrons, and they're 2 individual lone pairs, then each nitrogen has a total of 8 electrons, and we used the maximum we were allowed to use, which was 10. So now let's do some structures. This is when it gets to be quite fun. And I hope you guys enjoy this as much as I do, because we're going to actually start being able to put together models of different molecules. So when we put together a bond, a single line will represent 2 electrons bonded together. And so if we have a double bond, we would have 2 lines like so. So here we have 2 lines between them indicating there's 4 electrons being shared. And 3 lines means we have a total of 6 electrons being shared. And, double check. Here's 2 electrons, so hydrogen's happy. 2 electrons, hydrogen's happy. Here, 2, 4, 6, 8. Carbon is happy on either end, and everybody is good to go. So we will then continue with molecular polarity with the next video.